In mathematics, groups and coding theory is a very important topic. So today we start with the some topics from groups and coding theory. Now the first unit is integers. Now the next point is Euclid's lemma. Now to prove Euclid's lemma we need one theorem. If p is a prime such that p does not divide an integer a, then GCD of a and p is equal to 1. For example, see 3 is a prime number and 3 does not divide integer 7. So in this case, GCD of 3 and 7 is 1. Similarly, if p is any prime and p is not dividing an integer a, then always GCD of a and p is equal to 1. It means a and p are relatively prime or co-prime integers. Now see actual statement of Euclid's lemma. If p is a prime that divides a into b, then p divides a or p divides b. So if p is any prime integer dividing the product of two integers a and b, then definitely p will either divide a or p will divide b. Now see what is the proof. So the given part is p is prime dividing a multiplied by b, and we have to show that p divides a or p divides b. Suppose p is a prime that divides a into b but does not divide a. Because if p divides a, then obviously the result is true. So we are assuming that p does not divide a. So if p is not dividing a, then in that case we have to prove p divides b. We must show that p divides b. As we are assuming that p does not divide a, by previous theorem GCD of a and p is equal to 1. Now already we have seen that GCD can be expressed as a linear combination of given integers. So the GCD1 can be written as linear combination of a and p. For that there exist some integers s and t such that 1 is equal to as plus pt. Now call this equation number 1. Now we multiply equation number 1 by b. So 1 into b is b. Similar way, multiplying right side by b we get it is asb plus ptb. Now the given part is p divides ab. Now as p divides ab, p divides abs. As already we have seen one result that whenever a divides b, a divides bc. So by using that result, p divides ab gives us p divides abs. Also p divides p because any non-zero integer divides itself. So p divides p implies p divides ptb. Now, whenever A divides B, A divides C, A divides B plus C. So, using this result, we get P divides ABS plus PTB. But ABS plus PTB is nothing but B. So, finally, we get P divides B. So, when P does not divide A, then in that case, P divides B. So, this is the proof of Euclid's lemma. That is, if p is a prime integer dividing a into b, then p divides a or p divides b. Now see the remark. Euclid's lemma may fail when p is not a prime integer. That means if you consider just p as an integer which is not prime, dividing a into b, then not necessarily p divides a or p divides b. For example, 6 divides 4 into 3. So here 6 is dividing the product 4 into 3, but 6 does not divide 4 and 6 does not divide 3. So this is happening because if you observe the integer 6, it is not a prime integer. So Euclid's lemma holds only p is a prime integer. It's lemma. Now already we have seen the concept of greatest common divisor. Similarly, another definition is least common multiple, that is LCM. Now see the definition. Let a and b be two non-zero integers. Then the least common multiple LCM of a and b is defined to be a positive integer L such that a divides L and B divides L. It means L is a common multiple of A and B. Secondly, if A divides C and B divides C, then L divides C. It means if C is a common multiple of A and B, then L divides that C. So condition 1 ensures that L is a common multiple of A and B, while condition 2 confirms that this L is least among all common multiples of A and B. Now see what is the notation of LCM of AB. So either we can write LCM in round bracket A comma B, or we can use square brackets A comma B as the notation of LCM of A and B. Now see one example to clear the definition of LCM. Now here we find LCM of 6 and 10. Now see, it is least among all the common multiples. Now first find multiples of 6 and 10 separately. Now multiples of 6 are 6, 12, 18, 24, 30 and so on. Similar way multiples of 10 are 10, 20, 30, 40, 50 and so on. So what are the common multiples? So the common multiples are 30, then we get 60, 90 and so on. So there are infinite common multiples of 6 and 10. But among all these common multiples, least is 30 because 30 divides all common multiples of 6 and 10. So LCM of 6 and 10 is 30. Now, what is the relation between LCM, GCD and given non-zero integers A and B? So the relation is that for any non-zero integers A and B, LCM of AB is equal to mod of AB upon GCD of A comma B. So mod AB is nothing but absolute value of A into B. Now here in this example, this is nothing but GCD. So GCD of 3587 and 1819 is given as 17. And we have to find their LCM. Now GCD is given, two integers are also given and we have to find their LCM. So we are using directly this result that LCM is equal to mod of AB divided by GCD of AB. Now A in this case is one integer, that is 3587, B is 1819. So substituting all these values in equation number 1, now we can write LCM is equal to 3587 into 1819 divided by GCD, which is 17. So the answer is 3,83,809. So two integers GCD LCM. Out of these four quantities, if any three quantities are given to us, then we can find the remaining quantity by using this